Hi everyone, this is Rishi from GVO, and today we are talking about conversational user interfaces. If you have used ChatGPT, Pi, Anthropic's Claude, or a whole bunch of other large language model powered chatbots, you have used a conversational user interface. The popularity of these chatbots has meant that we often think of chatbots as the only conversational user interface. But actually, as we will see in this video, the natural language understanding capabilities of large language models allow us to build conversational user interfaces for a variety of different applications, not just chatbots. Reporting, analytics, dashboarding, these are very common applications. This is where you build a screen or a dashboard where you can query your data. This data is often rendered as graphs, tables, and so on. All of this is driven by the questions, or more relevant, the answers that your users want from your data. So in this demo, we will show you how we built a tool that bypasses the SQL query or stored procedure creation phase that often requires some expertise. We allow a user to make queries using natural language and then use the code generation and natural language understanding capabilities of large language models, in this case GPT-4, to generate the SQL queries and then render the data back to the users. Now, this is a very simple demo, and this is very much a proof of concept. But the idea behind it is for us to demonstrate the capabilities of these models in building complex and useful user interfaces without having the linear workload of adding a new query or new stored procedure every time that a new type of question is asked by your users. We think that this approach of building a conversational user interface will allow for much more flexible and complex applications that can be built quickly and deliver value to your users. I hope you enjoyed. Please follow us on LinkedIn or check out the GVO website for more information about our experiments with building on top of LLMs. Okay, so we are going to do some demos and see how we can generate interesting SQL queries from prompts. So we'll start with something simple. Show me the number of active employees. So this is a relatively straightforward query. Should work pretty easily. Does a count, select count from the employee table where active equals 1. Okay, let's make it a bit more interesting. Who are located in the city of Vadodara. So in this case, we have a column in the employee table called location city. So what the model is able to do is to determine that the city of Vadodara corresponds to the column location city, and it still does the other conditions. Now let's add something here where we are looking at a skill. So let's find out employees who are located in the city of Vadodara who know Java. So I'm gonna run this query here. So this requires a join in 3 tables. So we have an employee table, we have a skill mapping table, and a skill table. So here we go. We have a little bit more complex query where we're joining on the employee, skill mapping, and skill table along with these conditions. So we can now continue to add more conditions here, but the idea that I want to show is the ability of these models to take a text prompt, look at the hints that we're giving in the text prompt, and translate it into a useful query and get results out. Okay, so let's look at how we actually get the GPT-4 model to generate our SQL query. So here's some code. Here are the tables that we are interested in. We have the employee table, we have the skill table, and the skill mapping table. We have various columns here, And then we have the prompt that we use to generate the SQL from the text. Okay, so the prompt starts with the usual persona. You're a useful assistant. This is what you're trying to do. You're going to generate a SQL query given a database schema, and then we give the model steps, what steps to take. So we say, determine which tables are relevant, which columns are relevant, join, and then we also give some guardrails here. So we say limit the output to select statements, and the generated queries must not modify, delete, or insert data into the database. The prompt also includes the database schema. Now, this is not really a DDL, this is not SQL, this is just an outline of the schema. This includes things like the data type, as well as hints about what this column means. So we say that, okay, the location city is the city where the employee is located, location country is a country where the employee is located. In our testing, we found that not including these hints still results in reasonable queries, but including these hints just makes things a little bit more predictable. In general, what we found is that by giving more explicit prompts, along with giving the model time to think, i.e. by asking it to go step by step, and giving as much data as possible in the prompt, we get good results. So this is a pretty straightforward prompt, but it took us a little while to figure out what format the database schema should be in to keep it straightforward, what sort of hints are required, and how this whole thing sort of hangs together. So the output from this prompt is a string that comes out of the model, and then we do some further validation on the string, and then we execute the SQL, and then we return the results as we saw in the earlier demo. So I hope this gives you a little bit better idea of how we are building interesting conversational user interfaces on top of large language model capabilities.